Whereas coming to the closed loop system, location of the roots, it becomes s plus 3 plus k is equal to 0. So here the location of the roots depends upon the open loop gain k. So we need to draw the plots for all the values of k from 0 to infinite. How the plot varies, whether it goes to RHS of the S-plane or it terminates in only LHS of the S-plane. That we have to identify. So for that, we go for Rootlocus plot. There are some set of rules to construct the Rootlocus. The first one is, first find the location of poles and zeros. After that, we need to locate these poles and zeros on the S-plane. See here we have only 3 poles. Those poles are located at 0, s equal to -2 and s equal to -3. While representing the poles and zeros on the S-plane, we have to represent the 0 with circle and pole with cross symbol. And next, we have to identify the root loci path, the region over which the path will be there. So for that, there is a rule, that is, if you consider any test point, to the right of the test point, number of poles and zeros must be in odd in number. Suppose if we consider this as a test point, to the right of this, how many poles are there? Only one pole is there. There are no zeros. 1 is an odd number. So this point lies on the root loci. Similarly, you may test any point between these two poles. All the points lies on the root loci. Try to highlight this. So this entire path will be on root loci. Similarly, if you test a point here, then to the right of this, I have 2 poles and no zeros. Sum of the poles and zeros is 2. It's an even number. So this point doesn't lie on the root loci. Next, if you consider a point here, then to the right of this point, I have 3 poles. There are no zeros. As 3 is an odd number, this point lies on the root loci. Similarly, you may test any point up to infinite that lies on the root loci. The next point is, see, from each and every open loop pole, one path originates and it travels along the root loci path. So when I consider this pole, from this, one path originates, but in which direction it travels, whether in this direction or in this direction. Here I have root loci path. That's why the path travels in this direction only. Similarly, from this loop or from this pole, the path travels in this direction. And when you come to this pole, one path originates here, but in which direction it has to follow? Along the root loci. So in this direction it follows. So I have 3 poles and 3 paths are being originated from these poles. The next point is, we have to find the asymptotes. First, let us find the number of asymptotes. Number of asymptotes is equal to m minus n, that is number of poles minus number of zeros. I have 3 poles and no zeros, so I will get 3 asymptotes, and their corresponding angles are theta 1, theta 2 and theta 3. And for theta, formula is plus or minus 180 into 2q plus 1 divided by m minus n, where q is 0, 1, 2 up to m minus n minus 1. So m minus 1 is 3, 3 minus 1, 2. So q varies from 0, 1, 2. When I substitute q equal to 0 here, I will get 60 degrees. When I substitute q equal to 1 here, I will get plus or minus 180 degrees. I will substitute q equal to 2, I will get plus or minus 300. So these are the angles of asymptotes. I have 3 angles of asymptotes. Those are 60, 180 and 300. Next, where does these angles intersect on this real axis? That is nothing but centroid. Let us find the centroid. For centroid, formula is C is equals to sum of the real parts of poles minus sum of the real parts of zeros divided by number of poles minus number of zeros. So for that, we will get divided by number of poles minus number of zeros is 3. That is minus 5 by 3. That gives minus 1.67. So at minus 1.67, I have the intersection of asymptotes. Let us say this is sum of 1.67. At 1.67, what are the angles of asymptotes? 60, 180 and 300. All these asymptotes will be intersecting here. Let me clear this. So these are the angles of asymptotes along 60 degrees, along 300 degrees and along 180 degrees. The next point is, see, when I have two paths originating from these two poles, as the open loop gain K increases, these two paths moves towards each other, and still if you are increasing K value, these two gets break here and goes away from that. That point is said to be break away point. Here we have break away and break in point. Break away point occurs between two poles on the root loci, and break in point may occur between two zeros or between a 0 and infinite. So here we don't have zeros, so we'll get only break away point. So break away point can be obtained by solving dk by ds is equal to 0. From the characteristic equation, first let us find the k value. The characteristic equation is s into s plus 2 into s plus 3 plus k is equal to 0. From this, I'll get minus k is equals to s into s square plus 5s plus 6, that is equal to s cube plus 5s square plus 6s. This is minus k. I have to find dk by ds. Let me find the dk by ds, that is 3s square plus 10s plus 6 is equal to 0. From this, the s values are